Hello everybody, this is Mr. Molikash again. This is our week 9 video for Math 172 at Johnston Community College in Smithfield, North Carolina. If you're watching this video, you can contact me at this email address. I'm an adjunct math instructor at Johnston Community College, so I'll be answering questions primarily from my students. This week we're going to talk about the law of sines, and the law of sines is used to solve a triangle that may not have a right angle in it. So we have these three sides of a triangle, right? And we call them A, B, and C. They're lowercase letters for the sides. The capital letters are used for the angles that are opposite these sides. So here's angle A, opposite on the other side of the triangle from side A. You can imagine yourself standing at the corner of a triangular field. If you're standing at the vertex of angle A, you can touch sides B and C. They're adjacent to you. But you cannot touch side A because it's all the way on the other side of the triangle, unless it's a real tiny triangle and you can reach all three sides. Okay? So where's angle B? Where's capital B? It's going to be up here. And capital C is going to be right here. Okay? In this triangle, there's two ways to talk about the law of sines, and you can do either one. So one way is to put the sides on top of two fractions, A and B, and then the sine of its opposite angle goes on the bottom. Okay, so these two things are equal in any triangle, this fraction is always going to equal this fraction. And it doesn't matter which sides we pick, so we could just as well do sides B and C and the sines of their opposite angles. So sometimes you'll see, and sorry, that should be a smaller C. Sometimes you'll see all three of these put together. In practice, though, you'll only use two of them. So you can use the first two, you can use the last two, or you can use the first and the third. Okay? So it just depends on which angle or side is missing that you want to find out. Of course, you can flip all these over. So if you flip any one of these fractions over, you have to flip the other ones over to match, right? So the law of sines is sometimes written like this. I like the first version better, but it doesn't matter, honestly, which one you use, okay? All right, so you're primarily going to use this when you are given two angles, okay? When you're given two angles, you could be given two angles and then a side, or you could be given two angles and then the side between them. So for example, if we had angle C and angle B, then the side that's not between angle C and angle B could be either one of these, right? This could be little b or little c, okay? So in angle side, the letters match, right? You either have the side that goes with this angle or the side that goes with this angle. And again, these are opposite from each other in the picture, right? Another thing you could have to do this, again, this is for the primary use of the law of sines, is let's say that you are given angle B and angle C, and let's say you know the measures of these two angles. Well, the side that's between them is, in this case, little a. So if you're doing angle side angle, all three letters don't match. Whatever angles you have, you use the other lowercase letter for the side. Okay, so the purpose of this video, though, is to show you what happens when you're given one angle. So if you're given one angle, the only way that you're going to be able to use the law of sines is to have two sides and the angle not between them. And so you have, for example, maybe side A and side B, right? So this angle would be either angle A or angle B, right? Again, if the angles between them, the letters don't match, right? You'd have angle C in sides A and B. So this would be side angle side. And that is going to be what we'll deal with next week with something called the law of cosines. Okay, when this happens, when you're given two sides in an angle, you can have 0, 1, or 2 solutions. So we're going to look at some examples of why this would happen, okay? So this is going to be the primary focus of the rest of this video. So what I'm going to do is give you some information. We'll give you some information from a problem in the book. So let's say that we're given that little a is 185. That's a long length, right? 185 of something, inches, feet. Little b is 132. And then we'll say angle C is 63 degrees. Okay, before we get started, you're going to need a calculator handy. You can use a simple one like this that has sine, cosine, and tangent buttons. And you also want to make sure that you're in degree mode. Okay, if you're not in degree mode, you need to change your calculator to degree mode. And that depends on what calculator you have. Okay, so I'm good. Mine's already in degree mode. If I change this and do second DRG, then I'm in radian mode. And I don't want to use radians for triangles. Radians are for graphing or for the unit circle. You can use radians in triangles, but most of the time we don't. Okay, so here's the problem. Okay, and I'm going to do the solution right underneath this. So first off, we got to pick which two fractions we're going to use out, right? So, well, none of these letters match, right? Oh, yeah, I messed up. This is actually letter C, not A. My bad. Okay, this is letter C, so scratch what I said earlier in the video. This is actually letter C. So, all right, what I'm going to do then is I'm going to use the fraction that has the C and the C in it. And I have side A, so I'm going to use this fraction, right? And I'm going to plug in what I know, right? So 185 over sine of some angle that I don't know, right? We're going to find that out, is equal to 132 over the sine of 63 degrees. Okay, so what I'm going to do is cross multiply. So I have 132 times the sine of A, so this product, and then this cross product here, 185 sine 63 degrees. Okay, and then of course I have to divide both sides by 132. The goal here is to get angle A by itself, right? Angle A. So at this stage, what you don't want to do, and I'll put do not, I told you 5 times, do not divide by sine. That's a sin. Don't do that. Okay? SIN is not a number, so you shouldn't divide by it. Okay? So what do you do to get rid of the sine? Well, you do the inverse of this operation, right? We're not multiplying by A. We're doing the sine of angle A. So right now, we're going to say preliminary, angle A is the inverse sine of all this junk. And the good news is we can put all this in our calculator, right? Okay. So what we're going to try to do is we're going to use our calculator. Let me move this over a little bit so I can fit the calculator on the screen. So what I'm going to do is, being that the calculator that I have, I can't type it all in at once and very easily unless I use some parentheses or something. So I'm going to do the sine, well, 63, and do the sine of it. All right, so I'm good there. Now I'm going to multiply that by 185. And now I'm going to divide that by 132. And, oops, let's try that again. So I'm going to take the sine of 63 degrees. All right, multiply that by 185. Okay, divide that by 132. I hit the negative instead of the equal sign. Okay, now Houston, we have a problem. Houston, we have a problem. Remember from the unit circle that the sine of any angle, the biggest it could ever be is 1, and that's when the angle's 90 degrees. Remember the top of the unit circle. At your 90 degree angle, the cosine is 0 and the sine is 1. But there's no angle whose sine is bigger than 1. The rest of these are, 1/2, square root 2 over 2, and so forth. So when I take my calculator and try to do the inverse sine, I'm going to do second sine, I'm going to get error, which means that this problem has no solution. So let's discuss why that happened again one more time. It's because this value was greater than 1, which means no solution. The sine cannot ever be greater than 1. And if it were equal to 1, the angle would be 90 degrees. But otherwise, this number is always going to be less than 1. So this one has 0 solution, okay? All right, let's look at another example and see what might happen with some other given information. So let's go back in time here and let me erase my circles. All right, so let's say that you have little a is 13. Let's say little b is 18. And angle A is 45 degrees. Okay? Now, being that the angle is 45 degrees, we know the sine of 45 degrees from the unit circle. It's square root 2 divided by 2. But for the purpose of this exercise, I'm still going to use a calculator, okay? Okay, what fractions are we going to use? Well, we're going to use the fraction that has a and a in it, right? I'm also going to have to use the fraction that has side b in it. So for this exercise, I'm going to use these two. And again, I'm going to plug in. So 13 over the sine of 45 degrees. And again, if the book uses it the other way around, you can do the sine on top and the side on the bottom. But just remember, if you flip one side over, you have to flip the other side over. And when you cross multiply, it all comes out in the wash. So no worries. All right, 18 is the side length, and then the angle we don't know, but we're going to find the sine of that angle on the bottom of the fraction. So we're going to still cross multiply, and I'm going to put this actually the other one first. So I'm going to do 13 times the sine of b. I always like to have the unknown quantity on the left side. You don't have to do that. You can put them on opposite sides if you want. All right. So I'm going to divide by 13. I can do that because 13 is a number that's multiplied by the sine of the angle, right? So, but what I don't want to do is divide by sine. That doesn't make sense, right? All right, so what I'm going to do is I'm going to put this in my calculator and hope to find the inverse sine of it. So in this exercise, I want to really see, since especially after doing the last one, I want to really see if this is 1 or bigger than 1, okay? So back to the calculator. We're going to do the sine of 45 degrees, which, again, we know, but there's the decimal for it. We're going to multiply by 18, okay, and then we're going to divide that by 13. Okay, so we get a number that's less than 1, which means we have at least one solution, okay? And I'll write this out. Now, in this problem, it's important in problems like this to not round anything off until the very end. If you rounded this off to, say, 0.98, or much worse than that, 1, your angle would be slightly off, okay? If this were 1, B would be exactly 90 degrees, but this is not 90 degrees. Now, I'm going to stop and talk about this for a moment before proceeding, because we're going to revisit the unit circle, okay? So here's 0 degrees. Here's 180, here's 90 up here, right? Okay, so the sine, if angle B is acute, then the angle's in the first quadrant, right? So we'll draw it like right here, okay? And the sine, we don't know what the cosine is, but the sine is 0.979, whatever. But we need to remember that there's another angle that it could be an obtuse angle, an angle between 90 and 180, that has this same value for the sine. So it would be the opposite of the question mark for the cosine. The cosines are opposite, but the sines are exactly the same. Okay, so because of that, and I'm sorry that this marker was really thick, but hopefully you get the idea that there's two possible answers to this question. Okay, now the calculator will only give you one of them. The calculator will give you the acute version of this angle. Okay, so we're going to have to try to find that solution first, and then we'll test the other one out. Okay, so how do I find the acute angle B? The way to find the acute angle B is to take this number that I got in my calculator and do the inverse sine of it. So second sine. All right. And all right, so 78, now I can round off, 78.26 degrees. All right, so if indeed angle B is 78.26 degrees, then I can start filling in some stuff, right? So again, let's look at this. A was 13, B is 18. Angle A was 45 degrees. Let me see if I can do this without smearing all the ink here. And angle B, now we know, at least if angle B is acute, it's 78.26 degrees. All right, immediately we can find a third angle here, and hopefully you know how to do that, right? You subtract these two from 180 and you figure out what's left over here, right? Which is great. So I trust that you know how to find that angle, and then what you can do is you can use this fraction and this one and do the law of sines all over again to find side C. So there you would do 13 over sine 45 degrees equals little c over the sine of this 78.26 degrees, which was this number, right? So you can cross multiply and easily find out what C is, and then you've solved the entire triangle. You have all three sides and all three angles. Okay, but now what we're going to do is look at, again, this unit circle, right? If angle B is acute, then it's 78.26 degrees. But remember that there's an obtuse angle over here that the calculator won't tell me, and its sine is this number as well, right? So the way to find that is to use reference angles. So, okay, 0 to 78.26 degrees is an angle that's already written there, right? But to figure out what number this is from 0, I have to take 180 and subtract 78.26 degrees, okay? So the slick trick to do that in your calculator is to make that number negative and then add 180 to it. So that's the slick trick to subtract from 180. All right, so the other angle B is 101.74 degrees. So I'm going to write that down here. The obtuse angle B is 101.74 degrees. Okay, now how do I know if this one works in the triangle? What I have to do is come back up here in my picture, okay, and put 101.74 there and ask myself, is there enough out of the 180 degrees in a triangle, is there enough left over for a third angle? And there is, right? So if I add 45 degrees to this, that's the sum total of these two. And then if I do the opposite and add 180, the third angle in this case would be 33.26 degrees. So this one has two solutions. Okay, I didn't work out the entire solutions, but I hopefully justified for you why there are two solutions. So what would I do to find side C? Well, that 33.26 degree angle would be here, and I'd still use those same two fractions, but this time I'm putting a different angle in for C, and then I could cross multiply and find side C. All right, so that's a triangle that has two solutions. You might be asking me one more time now, how do you know if there's only one solution? Well, let me give you an example where there's one solution, and I'm sorry, I'm going to have to take a little bit of time here to erase a bunch of stuff. Okay? So this is a generic picture. Doesn't necessarily need to be drawn to scale. I have some picture of triangle ABC with the sides opposite them, and I put the given information in here to try to piece together the rest of this. All right, so, all right, let's say we're given angle A is, side A is 6, and side C is 12. And angle A is 30 degrees. Side A is 6, side C is 12, and angle A is 30 degrees. Okay, so again, we're going to have to use this fraction in this one, and we're going to plug in. So let me also, while I'm here, put this stuff up here. Okay, so this is side-side angle. This is called the ambiguous case, by the way, because the answer is ambiguous in possible two solutions, right? If there's two solutions, then the triangle's ambiguous. It could be acute or obtuse. All right, so what we're going to do is we'll put 6 over the sine of 30 degrees, and we'll put 12 over the sine of angle C, which we don't know, right? And again, we're going to cross multiply. Same stuff that I did before. And then we're going to, sorry about the noise in the background, they're doing construction outside my window. So what we're going to do is put all this in the calculator, right? We're going to put all this in the calculator. So let's see, we're going to do the sine of 30 degrees. If you remember this from the unit circle, then you are awesome. It's 0.5, which is 1/2, right? So that's on the unit circle, the sine of 30 degrees is 1/2. We're going to multiply that by 12 and then divide that by 6. And we get exactly 1. Wow. Remember what I said when that happens? In this case, C is going to be 90 degrees. And like the song says, if you don't believe me, just watch. If you do the inverse sine of this, you get 90. So this is not ambiguous at all, right? If you look at the unit circle, okay, if you have 90 degrees, there's only one point on the unit circle whose sine is 1, right? And by the way, 180 minus 90 is still 90. So the answer is 90 degrees no matter how you do it. All right, so we could solve the rest of the triangle then pretty easily, right? Since we know that angle C is 90 degrees now, okay, you could subtract these two from 180, so that's 60 degrees, and now you can use the law of sines with these two, right? So to find out what side B is, all right? So I'll do this one to go ahead and finish this solution since I didn't do it with the earlier problems. Sine of 30 degrees equals, now this time I don't know what B is, so I'm going to put B there, and I'm going to do the sine of 60 degrees because that's what I found out by doing the subtraction up here, right? So I have B times the sine of 30 degrees is equal to 6 times the sine of 60 degrees. Okay, now remember earlier when I said don't divide by sine? And the reason you don't want to do that is because you don't want to divide by the sine of 30 degrees because, I mean, by just sine, because sine is not a number, but you can divide by the sine of 30 degrees. The sine of 30 degrees is a number, and we can find it in our calculator. In fact, it's 1/2, remember that? So you never divide by sine by itself, but you certainly can divide by the sine of a number. And that gets B by itself. So what we're going to do is all this gets put in the calculator. So 60, the sine of that is some crazy number. We multiply that by 6, right? And then we divide by 30 sine of that, and then hit equals. Okay, so little b is 10.39. All right, now when we're done solving a triangle, okay, when we're done solving a triangle, you want to take a look at this triangle and make sure that it makes sense. So what do I mean by that? Well, making sense means that the shortest side is opposite from the smallest angle, and the middle side is opposite from the middle angle, and of course the longest side is opposite from the largest angle. So if that happens in your solution, it's almost a guarantee that you got it right. If you have a really long side here and a really small angle here, that doesn't make sense. There's no way to have a really long side and opposite from that have a small angle, because then the other sides wouldn't meet each other and you wouldn't have a triangle. All right, so that's it for the law of sines this week. Next week we'll have another video for the law of cosines. Hope you enjoyed this. Have a great week.